For this exercise, you will be calculating odds ratio, relative risk, and 95% confidence intervals by hand as well as in SAS. For the first part, you conducted a cohort study and you developed the following 2 by 2 table based on your study results. What is the odds ratio and 95% confidence interval of this cohort study? You can calculate them using these formulas from your lecture slides. For the second part of the exercise, you conducted a cohort study and you developed the following 2 by 2 table based on your study results. What is the risk ratio and 95% confidence interval of this cohort study? You can calculate them using these formulas from your lecture slides. For the final part, you conducted a cohort study and developed a similar 2 by 2 table. And now you have to calculate the odds ratio, relative risk, and 95% confidence intervals in SAS. Let's look at the SAS program for the required calculations. In order to get calculations from SAS, we need a data step and a procedure step or the proc step. In the data step, we input data into SAS. The statement data tells SAS the name of the data set. The statement input is used to tell SAS which variables will be used. The $sign in front of the exposure and the outcome variables tells SAS that these variables are corrector variables. The statement cards is used to enter data into SAS. This is the way how a 2 by 2 table is written in the SAS. The count of exposed and diseased is 535. The count of exposed, non-diseased is 1650, and so on. The run statement completes the data step. The procedure step uses the proc freq to produce odds ratio, relative risk, and the confidence interval. Order is equal to data orders values according to their order in the input data set. The weight count statement is used to input cell count data, that is 535, 1650, 140, and 725. The tables statement with exposure into outcome will produce a 2 by 2 table in SAS output. And the options chi-square and rel risk will produce the SAS output with odds ratio, relative risk, along with their confidence intervals. Again, the run statement completes the procedure step. This slide shows the SAS output for odds ratio and relative risk. You can see the value of odds ratio to be 1.67 and 95% confidence interval limits for odds ratio to be 1.36 to 2.06. The value of relative risk is 1.51 with 95% confidence interval limits 1.27 to 1.79. Now compare your SAS output with the numbers calculated by hand and see if they are same or not. They should be similar. To calculate the risk difference in SAS, put the risk diff statement right here. So this slide shows you the SAS output for risk difference. For a 2 by 2 table, that has been set up like this in SAS, you have to look at the column 1 risk estimates. For our data, the risk difference is 0.0830, which means that the risk in exposed is higher as compared to those in unexposed. It is very important to see how you have set up your 2 by 2 table in SAS, because the interpretation of risk difference with respect to exposure and disease depends upon how the 2 by 2 table has been set up.